Suppose in this min hash example, you have to take random permutation. So all the rows you need to be take. Okay, how many rows are there? One, two, three, four, five, six, seven rows are there. The same rows we are using and we are randomly permitting. Once you randomly permitted, you try to find the signature of the matrix. Signature of the matrix. In the signature of the matrix, you know how to calculate the signature of the matrix that we discussed in the last class. The same way you need to find all the signatures. So the finally you need to be calculate the signatures and similarities. Now we are landing the main task in our discussion, that is locality sensitive hashing. Most of you know what is the usage of hashing. Anybody can explain to me what is the main purpose hashing designed? Any one of you answer for me? How hashing can be used? May I get some answers from any one of you? Hello? Let me ask questions from some of you. Kalpit, what is hashing and why hashing is required for us? Kalpit Agarwal, can you unmute the mic?
Yes, sir.
Can you tell me why hashing is required? How hashing we were going to be used for?
Sorry, sir. ना ये प्रीवियस क्लास आई हैव नॉट मतलब सर मैं अटेंड नहीं कर पाया था, कुछ प्रॉब्लम हो गई थी.
Okay. Then Nishant, can you able to? This is the general discussion only. I'm not talking about anything. Kalpit, just general hash function I am talking about.
ओके सर.
So do you know general hash function? What is the purpose general hash function we used?
सर
And
हम कुछ ऐसी वैल्यू बनाते हैं कि जिसको हम रिवर्स में मतलब हम वापस अपना वैल्यू नहीं ले सके. जैसे कि हमने एक ऐसा फंक्शन बनाया जिसके अंदर हमने कुछ अपना स्ट्रिंग डाली, तो उसको एक ऐसा हैश वो कोड बना देगा जिसको आप रिवर्स नहीं कर सकते और वो यूनिक हो.
Syed is raising his hand. Can you unmute and can you explain, Syed? Syed Aman. Hello. You can unmute and you can discuss. Keshav, can you unmute? Keshav? Geetansh Mudra? Jayesh?
यस सर. सर
Can
हैशिंग.
you, hello?
हेलो.
Can you able to give okay, small information about hashing? Why we are using hashing and how we are using hashing?
Sir, hashing is used to reduce the data key size, and even we can to increase its security of the data.
What is the general purpose? You can explain about the general purpose of hashing.
Its general purpose is used for mapping function
Mhm.
between various key value pairs.
Okay. right? Anyone else add to this Jayesh answer? Karan Bhatia? Karanveer Sharma? Karanveer Sharma? Neeraj? Mayank?
Yes, sir.
Mayank, what is the purpose we are using hashing in our computer science?
So can you again explain what you are saying?
Hashing is a concept we are using for several purposes in our computer science. Can you give
Yes,
us a few of them and how we are using hashing?
sir. Basically, hashing we are used for data integrity verification and
Hmm.
also for password storage.
Hmm.
And
Hmm.
in in case of data mining, we use hashing to reduce the data set.
So, right, you are saying everything correct. Indexing is also one of the major application for the hashing. Huh?
Yes, sir. We also use hashing in indexing, sir.
Hashing indexing. So, okay, generally you may observe in all this discussion, hashing is used for a single purpose. What is it? Do you have any idea on that?
Sorry, sir, I can't recall it right now.
Okay, anybody can answer for this question. Why? Because I'm asking in a general computer science, okay, we are using hashing, right? In that hashing, we need to be find somebody is messaging, right? Okay, Gautam, can you elaborate it?
Sir, we use sir hashing sir mainly for storing sir data sir to reduce the space sir, disk size and searching it efficiently.
Hmm. That's perfect actually. But okay, here are we are in all the discussion, even integrity, he said, you were saying storing, you were saying searching purpose, and okay, you observe the commonality. Are we entertaining any collisions in this discussion?
Yes, sir.
Collisions are entertained or not?
Sir, collisions are entertained, sir.
You take integrity, we are not going to entertain the collisions, right?
Yes, sir.
And indexing point of view also, two files the same name, are you going to be accepted?
Sir, in hashing we store, sir. We accept it.
No, no, the key is different. I'm talking about, okay, two files are going to be mapped to same file. Two keys are going to be mapped to same file. Is it possible? No, no.
No, sir.
So that we call it as a collision. No? Collision we are not
Yes,
going to entertain. Am I correct?
Yes, sir.
That is the main motto behind these questions. The main point is going to be
Provide some similarities of files, sir.
that's why locality sensitive hashing point of view. So our main discussion here, locality sensitive hashing. Okay. Locality sensitive hashing is our main discussion. That I can say simply LSH. LSH, okay. You observe, suppose you have a X document, that X document, suppose, okay, generally in computer science, X is there, with help of hash function, we will find hash of X. In indexing also, what we will do, we will create a small index over here. Suppose, okay, in a normal file system point of view may form, so ABCD letters are there, A, B, and so on to Z. Means, okay, whatever the file started with A, you can join, that means that can join to this one, that can add to this one, such a way that, and so on. The file is going to be start with B, that can be mapped to B only, right? That can be mapped to B only. In such a way that a Z can start, it can be mapped to Z only. Means indexing purpose we will use like that, but no two documents are not supposed to be use same index, because that creates the collision. That creates the collision. Are you able to create any file like that? Suppose if you may take a new folder 1, new folder 2, it will come. Okay, so that okay, the path of that particular file is going to be the same. Because of that, you should not write the same file name for two different documents, two different files. Correct. So, in a normal integrity point of view, also, the hashing is not going to be entertain the collisions. Hashing is not going to entertain the collisions. Are you clear now? But in opposite way, we will use hashing for this particular locality sensitive hashing. What is that? Okay, what I can say here, it's missed out. Here you may observe very carefully, locality sensitive hashing is going to be quite opposite. You should entertain the collisions. Why we need to entertain the collisions? Anybody can guess why we need to entertain the collisions? Can you answer and unmute and answer for this question? Previously, in indexing point of view, integrity point of view, whatever other concepts are there, generally we were not support, we were not use, okay, collisions. We were not entertain the collisions. But here in the locality sensitive hashing point of view, we were going to be entertain collisions. Why and what is the main motive behind that to entertain? Means, what is the aim of our discussion? Our main aim is going to be find similarity, similar documents. Am I correct?
Yes.
That means we need to be find the duplications. So that purpose we try to find the collision. Whenever two documents hash value same means what? Both are different documents but the same content. Am I correct?
Yes.
So that is the main motive behind this. Okay, so that's why we need to be concentrate to understand, okay, hashing, how we are using, hashing we are using to find, okay, the similar documents. Why we are doing that? We have to group that. For grouping purpose, we need to find the similar documents. How we will achieve this one? With help of a concept, we call it as a bucket algorithm. You know bucket. Bucket means, you know, your radix sort or bucket sort, you might study it. The same way here also, you need to be sort all the minimal document information. So then all other documents are going to map to that one. So that's why here we try to understand two things. In the last discussion, false positives and false negatives we discussed, right? So the main approach here, we are finding a set of candidate pairs for a similar documents and then discovering the truly similar documents among them. This is our main target, right? So the complete procedure can use false negatives. False negatives. So once you have a false negatives, that should not be a candidate pair. If it is a false positive, then you can use and you can compute that, okay, candidate pair. Right. So how we need to be find this one? So that's why there are several concepts are going to be there to combining the techniques. So we already discussed we pick up a K and construct from each document the set of K shingles, and these K shingles are going to be shortened with help of a bucket numbers. So once we use this, then we sort the document shingle space to order them by samples. Order them by shingles. Then after we are finding min hash signatures, we are feeding the sorted list to the min hash algorithm, and we are finding some threshold T to define the similar documents, that is your signature. Then after we are finding and constructing candidate pair by applying the LSH, this that means locality sensitive hashing, and we will examine that pair of signatures, and finally we will going to be agree to a particular signature, and so that we will find the similar signatures, and we will use the similar signature to measure that means group the documents. This is the main idea behind this particular locality sensitive hashing to discuss. For this discussion, we need to be understand couple of things over here. What are the couple of things are there here? We need to be understand distance measuring. We know Jacquard similarity. So Jacquard similarity is going to be used to what purpose? Anybody can answer for me? Jacquard similarity we used for what purpose? May I get some answers from you?
Sir, to find the similarity between two sets.
Yeah, the majorly what we are going to find with help of Jacquard similarity, the closeness of the sets, means how close sets are. We are finding, but we are not finding the distance. Second, with help of the Jacquard similarity, what we are finding? We are finding Jacquard distance. So why we are finding Jacquard distance? Jacquard distance means 1 minus your Jacquard similarity. Again, here also, we are not only measure the closeness, and we are making some sense to examine that particular information with help of Jacquard distance. But the main point here is going to be how to measure the distance, and how this distance is going to be useful in our locality sensitive hashing is the main point for us. For that, we need to be define the distance. First, what we need to be define? Define a distance to measure something. So here we will take any two numbers and we will say something about the distance. In that case, we have several points over here to observe in the to measure the distance. Suppose I am writing d of x comma d of x comma y means here what this is going to be used to, it is a function which is going to measure a space between 2 points. Means it's going to be provide a real number between that means so that what we need to be write based on this particular d comma xy, we need to be prepare some exams. In that exams, what we can say, the exams are going to be, I can write here, the exams are going to be exams are going to be the first one. D of x comma y, which is going to be greater than or equal to 0, which means, okay, this means there is no negative distance. No negative distance. The second one is going to be if d comma xy is equal to equal to 0, if and only if x equal to y, means the distances are positive and the distance is going to be okay, is going to be at the same point itself, right? Next one, third point we need to be understand here, that is d of x comma y is equal to d of y comma x. D of y comma x. It helps us to measure the distance symmetry. Distance symmetric. It helps us to calculate the distance symmetric. D of x comma y, which is going to be less than or equal to, I can write here, less than or equal to later on, and d of x comma z plus d of z comma phi. This is going to be used to for triangle inequality. Here it is supposed to be used less than or equal to. Five. Sorry, here we need to be understand this is for what purpose? We should use this less than or equal to. And in this, out of these particular exams, the most typical and most complex conditions are going to be comes from this triangle inequality. Right? So the triangle inequality is what makes all distance measured on behalf of the distance described length or shortest path or point or whatever it is, we can measure it. So the most complex and most critical one is going to be this triangle inequality. Triangle inequality. So here we try to understand a different distance measure algorithms. Distance measure algorithms. So can you provide which one is going to be which one we will use to find the distance between any 2 points? Which algorithm is the very famous and well known to all of us? Can you name it? Euclidean distance. Euclidean distance. Euclidean distances, you know, so you take n-dimensional Euclidean space, you can find the distance between the points. So according to that, L2 now we can define based on the Euclidean distances that are going to be, suppose I can write two vectors. Suppose the distance of two vectors, suppose I may choose here x1, x2 and so on, xn. Comma here y1, y2 and so on, yn, right, which is going to be equal to square root of summation of I equal to 1 to n xi minus yi whole square. So, but completely it depends on the points are non-negative, the distance is also non-negative, and you should not be use xi equal to yi for any point. Right? So because of that, we are going to be find the similarities between the two documents. Okay, sometimes we may use this particular Euclidean distance also. Right? So Euclidean spaces also we will use. So the same, this is going to be called it as a L2 norm. We have two, that's why L2 norm, we can call this as a L2 norm. And the same way we have LR norm also. The space is going to be consist R constant values. We were supposed to be used for this. So that you need to be choose R and you have to find the values. Suppose R equal to 2, L2 norm. If R is equal to 1, that is going to be Manhattan distance. So what is the Manhattan distance? The Manhattan distance is going to be between 2 points, the sum of magnitude of the differences in each dimension, we call it as a Manhattan distance. Right? So L1 norm is going to be Manhattan distance, L2 norm we are going to be used for our Euclidean distance. Then after, we need to be talking about the second one is going to be Jacquard distance. Here, Jacquard distance. Jacquard distance, right? You need to be know, first of all, here you need to be understand two things. One is Euclidean L2 norm and L1 norm, LR norm. LR norm, how we need to be write the same equation we supposed to be used for R. That R is going to be, we will use summation of I equal to 1 to n of that means okay xi minus yi whole to the power r and to the power this okay we are closing this one. We are closing, that means that this bracket is going to be, I have to use the different colors for this brackets so that we will be understand very easily, huh? here to the power 1 by r. This r is a constant value. You can use any value over here. But this, whenever it is going to be L1 now, we are going to be calling it as a Manhattan distance. Okay, what is that? Manhattan distance. Manhattan distance, okay. Some other distances also there, like okay, LR norm, L infinity norm is also there. L infinity norm defined as okay, xi minus yi for all dimensions of I. For all dimensions of I, we are going to be treated as a L infinity norm. So L1, L2, LR and L infinite norm, we try to understand about that. So can you find, okay, just a small example I would like to give you based on these discussions. I would like to give you 2 points, 2,7. All of you can work it out this one and keep your answer. 2,7 is one value, one x and y value. Other value is going to be 6,4. Can you find L2, L1 and LR as well as L infinity norms? So what are the values? Can you able to post it on our, all of you, can you post it on the chat box? So first of all, what is the L1, L2? How you need to be solve L2 value? Square root of 6 minus 2 minus 6, sorry, 2 minus 6 2 minus 6 whole square plus 7 minus 4 whole square. So this is going to be equal to square root of, this is 4 square plus 3 square. And the same 4 square 3 square is equal to 25. 16 plus 9, 9 is equal to 25. 25 means value is 5. Right. Now you have to find L1 now. Yeah, many people are answering. That's good. L1 is 7, L2 is 5. What about L infinite?
Sir, actually, I'm having problem in the definition of Sir L infinite. So that is the
No,
greatest
yeah, largest difference between those two. So largest difference, what are they? One is a 4 and another one is 3. So max of 4 comma 3, max of 4 comma 3 is equal to 4 only.
Yes, sir.
Simple, है ना?
Yes, sir. Got
You
it.
have given all norms, you take it and find out which one is the maximum that you need to be take it. For example, here you need to be observed. Here you need to be observed. Suppose L1 we find, how we need to find L1? Your 2 minus 6, right? Plus 7 minus 4. 7 minus 4. This is going to be 4 plus this is going to be 3. So this is L1 is equal to 7. The same thing, suppose you need to be find L infinite. L infinite is going to be max of, here you need to find 2 minus 6, comma 7 minus 4. 7 minus 4. So this is going to be equal to,
4, sir.
okay, so max 4 comma 3. So the value is going to be equal to 4. Fine. So this is about the Euclidean distance L2, L1 and L infinity, L norm discussions. So now we need to be moved towards to the Jacquard distance, and we try to understand Jacquard distance. We know Jacquard distance and here also you need to create some exams to find the measure, to measure this distance. Ultimately the equation is going to be 1 minus similarity of x comma y. 1 minus similarity of x comma, that means the Jacquard similarity, 1 minus Jacquard similarity of the points we are treating as our Jacquard distance, right? So most of you know that the Jacquard distance, okay, easily you can find out. And here also 3 cases are there. The 3 cases is going to, one is non-negative, one is going to be equal to 0, another one is going to be d of x comma y equal to d of y comma x. That is going to, that means like both intersection and union are going to be same. Finally, we need to be talk about the triangle inequality. We already discussed about the triangle inequality in the last classes actually. So the point is here, if suppose you need to be go for a triangle inequality, d of x comma y is less than or equal to d of x comma z plus d of z comma y, such a way that. So here you need to be use the min hash function. With help of min hash function, you try to find the similarity between the documents. And one more distance is there, that is going to be called as the cosine distance. Is it? Cosine distance. This is the third distance, cosine distance. Right? In this cosine distance, we have to be find the complete space that have dimensions, including your Euclidean space and discrete version of your Euclidean space. Both you supposed to be used. Okay. So that the value we are going to be compute with help of L2 norm, that is going to be, suppose you have two vectors, product of two vectors are going to be x1, x2 and so on, xn, y1, y2 and so on, yn. Then we can suppose to be write the product is going to be like this, the summation of I equal to 1 to n xi comma yi, the product of these two, xi comma yi. Right, that means if you need to be take that means two vectors information and use that vector information for these two finding a cosine distance. That is simple. Whenever we are talking about the cosine distance, what exactly we are measuring? We are measuring the angle between the two points. Angle between the 2 points. That is going to be between 0 to 180 degrees only. So because of that, you need to be taken two vectors. The two vectors are going to be x comma y, and this x comma y we will use the cosine to find the angle. So after that, you need to use the dot product between the x, y and divide with the help of L2 norm of that particular x and y, so that you will get the value. Suppose example, I would like to give you two values over here, x and y, 1, 2, minus 1, 1 comma 2 comma minus 1, and another one is going to be 2 comma 1 comma 1. So how to find here? Here you need to be find, okay, 2 into 1 plus 1 into, sorry, this is 1, plus 1 into 2, 2 into 1, and here minus 1 into plus 1 minus 1 is like this. So which is going to be equal to 3. So you find L2 norm over here. If you find L2 norm over here, L2 norm is going to be square root of what value you will supposed to be find?
Sir, 6.
This is going to be square root of 6. L2 norm is going to be square root of 6. So that the angle between two values that are going to be 3 divided by square root of 6 and square root of 6, which is going to be equal to your 1 by 2. So 1 by 2 means how much degrees in cosine? 1 by 2. That means, okay, here you need to be take 3 divided by square root of 6 into square root of 6, which is going to be equal to 1 by 2. So 1 by 2 means cosine point of view how many degrees? Which might be equal to 60 degrees. So this is the way we try to find the distance for the cosine. And third, one more distance is there, that is going to be called it as a edit distance. What is called? One more is called edit distance. So this distance makes sense when the points or strings are there. A distance between two strings are going to be, how we need to be find? So the distance between two strings. So we have to define this edit string is going to be the distance between two strings x equal to x1 comma x2 comma and so on comma xn, and y equal to y1 comma y2 comma and so on yn. So is the smallest number of intersections and deletions of single characters that will convert x to y. This is the meaning. The distance between two strings x equal to x1, x2 and xn and y equal to y1, y2 and so on yn is the smallest number of intersection or and deletions of single characters that will be convert x to y. For example, here we need to be take the to find the distance. Okay, edit this distance. What we supposed to be find? Suppose you need to be take x is equal to a b c d e and y is equal to a c f d e g d e g. So now you have to convert x to y. If you want to convert x to y, what you supposed to be do? What we supposed to be do? In the first step, you need to be delete b. So delete b. If you delete b, what will be there? A, C, D, E is there. Then insert F after C. So that insert F after C. That it means what happens here? A, C. After that I am inserting F and D. Sorry. D, E, G. And in the third step, I supposed to be insert G after sorry, here there is no G, no, sorry, here there is no G. A, B, C, D, E only, after G. Okay, so that what I supposed to be do? Here, after that, what is there? A, C, F, I inserted D, E, and now I need to be insert another character G. So now what happens? 1, 2, 3. So one deletion, 2 insertions are there. So here what I said, intersection, now this is wrong again. Insertions and deletions, sorry. Insertions and deletions. So here 1 delete, 2 insertions. So the total distance is going to be how much? If I want to convert, that means what I supposed to write here, I want to convert D to x comma y, which means I am converting from x to y, which require three either insertions or deletions. So here, so we have to find this edit distance. That is also there. One more definition here. That is going to be LCS. LCS means longest common sequence. Longest common sequence. So that also we can use to define. Okay, longest common sequence of x and y is going to be treated as a edit distance also here. So here LCS we are finding for x and y is a string that constructed by deleting position from x and y, and that is as long as any string that can be constructed that way. So the longest common subsequent